God damn it. Oh, shit. Well, this is what happens when you, the first time when you ever start streaming, you forget to unmute the mic. I'm sorry, Dave Evans, if you're still here. Thank you for watching. I completely forgot to unmute the mic, and I've gone through a whole hour of this. Jesus Christ. Okay, well, if you guys are still here, I'll go quickly over this. Damn it. Okay. Okay. Well, let me briefly introduce the concept again. The whole goal of this streaming is to show the behind the scenes of basically building stuff that go into my YouTube videos. So that's the whole purpose of these streams. Basically more behind the scenes. Watch me build stuff, and then end product is going to be a YouTube video that happens probably months later. So this is more just like not really that entertaining, but more technical, more theoretical, more stuff like that. You know, that's what these streams are for. So if you're into that, feel free to watch. But the goal for this, I have an idea that I want a robot to shoot ping pong balls. And I want the robot to be controlled over the internet so you guys could play like a few games with me or something like that. I think that'd be very cool. So our design goal is to obviously shoot ping pong balls. That is the basic input of, or the output of the device. And we want to control the internet. As I said, I want to basically have you guys control it using some sort of API or some sort of chat or whatever. So that's what I want to do. Besides that, damn, I'm so disappointed that I didn't unmute the mic. We need the shooting mechanism. So essentially, we need the way to actually shoot the ball. Self-explanatory. We need live video feedback to control, for you guys to see how to aim and position the robot so you guys could shoot the ball effectively. We need a power source. That's a given. How do we turn on the device? How do we do stuff with the device? You want to do that. Damn. Hold on. Let me switch over here. I guess that one's working. Yeah, I just forgot to unmute the mic on that one. Okay. We need a power source, power transmission, meaning like how we're going to transmit the power so the robot actually does something. We're going to store several ping pong balls, meaning like, you know, we just need a reservoir of ping pong balls. And so we have several ping pong balls so I don't have to reload it every time, basically. Sensors, whatever sensors we need to make the robot work. This might be useful for the AI or PC component of the game. Maybe I want to play by myself, so I need an AI to play against. So we can use those sensors to tell the AI to do something. And when I say AI, it's probably not going to be an AI as what you think. It's going to be a very dumb version of it. It's probably going to be a random number generator, and that determines the position and then how far to throw the ball or something. Position control is going to be something like the orientation of how the ball is going to be thrown. So you could rotate around the ZX axis and then and so forth. You know what I mean? To determine where to shoot a ball. And then we started going deeper into each of these topics, being the first one, control to the internet. The first one being shoot the ping pong balls. We skipped that because that's more of just like the end goal. You don't really design that. It's just going to happen. The second one is control the internet. So that's what we went through here. What are we going to do? How we're going to do this. Hi, I can't say your name. Maleki? I can't say your name, but hi. So if you're new here, we're going through the process of designing a robot that shoots ping pong balls. I went a whole hour with my mic muted, so I'm briefly going over it now. So these are the several requirements: shoot a ping pong ball, control it through the internet, shooting mechanism, live video feedback, power source, power transmission. store several ping pong balls, sensors, position control, AI, and PC player. So those are potential. If you guys don't know, if you guys missed the stream by chance, you guys could watch it on my channel. These will be archived. So, um, so I went through this previously. We're gonna control this through the internet somehow. So you guys could control the robot and then shoot the ping pong ball, and then maybe play a few games of beer pong with me. But we'll get to that way later. But these are some concept generation how I think we should control the ping pong ball. If you guys have any ideas, feel free to let me know. This is our robot. We could do whatever we want to this, and then hopefully have something working at the end of it. If it doesn't work, shit happens. Um, so how I think we're going to control this through the internet is going to use some sort of API, some sort of social media website, Twitter, Twitch, YouTube. Um, yeah. So Twitter, we're gonna tweet out something. You guys at reply me on my main Twitter account, and then maybe the robot will listen for that command and do what it needs to do. So that could be any social media website. We don't really need to choose a specific one until later. So that'll be the whole programming thing when we get to that. So with the API, we need some sort of command, something so that the robot could actually read what you want it to do. So I came up with the idea like moving left 10 units, and then shooting 97. 97 being like the power of how far the ball is going to be shot. So I thought for a while, I think those are the only two things you need to actually position and shoot a ping pong ball. Like I try to imagine being like a gun, you know, if you had a gun, what do you need to do? You just need to position it and then pull the trigger. Like those are the two commands, very basic commands that you need to have this robot work. I mean, we could get fancy with it. Earlier I was speaking of how we could basically do a trick shot by knowing that the horizontal velocity of the ball is pretty much constant in terms of an ideal situation, meaning the distance traveled of the ball horizontally is only dependent on the horizontal velocity. So we could actually do some trick shots by changing the angle at which the robot is shot at, and then that will determine how high the ball will go. So if you want to be really fancy with it, we could send this ball like 10 feet in the air and then have it go the same amount of distance if we sent it like 3 feet in the air. But that, what I was talking about earlier, but that's more of a feature than it is a command that we need. So again, it boils down, in my opinion, to rotate and shoot. If there's more ways to shoot a ping pong ball, let me know. Like I think those are the two very basic ones that we need. Besides that, I also thought of like how the camera would work, because you guys will need to see a view of the cups or whatever target that we have to determine where you're gonna shoot, right? So the camera is gonna be live streaming back to maybe a little camera on the stream, a little view, so you guys could see, and then we're gonna use that so you guys could position the ball or the robot how you guys want. So I came up with like this crosshair, sort of like a sniper crosshair that you see in a scope or any other video game that you see. So that just helps with that. I mean, we can be very realistic and identify the drop of the ball, so that like if you do aim a little bit above, you could determine the drop of the ball when it's shot. I mean, maybe, I don't know. We'll see. I also thought of this little icon, so you know how many cups are left. You know, if there's a full formation, there'll be all the cups available. If you made a cup, you'll cross it out, and then, or you'll cross it out over here, depending on the cup, and then those remain until the game is over. And then I have these blue tick marks to determine the rotation of the bot. Originally, I was thinking of it in difference or displacement terms, meaning you could say rotate left 10, meaning you rotate left 10 degrees relative to the position you're already at. But I think it'll be easy to program it in terms of absolute terms. So, like you say, rotate 10, basically you go to the 10-degree position from wherever you're at. So it's not based on displacement, but based on an absolute position. So if I was at 30 and I say rotate 10, it will go to 10 degrees instead of 20. I think that's easier to code. So there's that. What we also can do, we can also repeat this process in the vertical direction. So whatever axis that we're rotating on. So we're rotating up. I'm thinking up and then rotating like this. So yeah, so like this and like that. So I think that's all you need to rotate for. And then we also have this power bar basically. So this goes with the power or the shoot 97. The 97 is a 97% power, and that'll tell you how far the ball will go basically, or how hard you want to shoot it. That's pretty much that. So that's more of the programming side of the graphics. How we're gonna do this, I don't know. I'm thinking a lot of Arduinos and Raspberry Pis. As in a lot, I mean one of each, more than likely. So I kind of wrote out the schematic or the flow diagram of how this thing would work. So we have basically you, me, or whoever wants to control this robot. You basically go to some Twitter or social media website. You go there, type in a command, and then the API will do something with it. And then it will convert it to something that the Arduino could read. The Arduino will listen to the website. So it's kind of like this feedback loop. The Arduino will listen to the website. The Arduino will understand the message, translate that to something so that the motors or whatever power transmission that we have for the robot, we could transmit it through there to them, and then the motors will tell the robot how to orientate itself, how far it should shoot it, and then the robot will basically tell the ping pong ball to leave. Okay. That was a very quick breakdown of what happened in the last hour. So, that's pretty much it. I'm sorry, like, I didn't know that my mute was muted. But my mute? Did I say mute? My mic. My mic is muted. I didn't know that. I'm very sorry. So, yeah. So what we can do now. Oh no. Hold on. Is the stream still good? Okay, we're back. Sorry about that. Okay. So we can go to the next process. I think we're good for controls with the internet for now. We're gonna go to the shooting mechanism. Now this is gonna be fun. I think this is like where the most of the fun of the design is going to be. So our shooting mechanism. So the goal of this, if you haven't noticed the trend, is to basically come up as many ideas as we can before we start actually building this thing. So we could choose our most optimal design, or maybe the easiest design, or whatever, before we start doing anything. So the shooting mechanism. I have 1 more hour, so we can probably get through this today. So I am so mad about myself about muting the chat. But if you guys have any suggestions or anything that you want me to know or suggest for the design, let me know. Put in the comments if you can't catch the stream. But yeah, let me know. Maybe we'll implement it. I won't shoot any idea down unless it's obviously ridiculous. But yeah, if you have any ideas, let me know, and we'll get it working. Okay. Shooting mechanism. Now, I've been thinking about this before starting the stream, to be honest. It's been an idea in my head for a couple of weeks now. I just haven't really fully thought it out as much as I have tonight. So, how are we going to shoot this ping pong ball? Well, there's one mechanism that I think we're fully aware of. Well, I'm not fully aware. At least tennis ball players are aware of. We have like some sort of mechanism that launches the ball using a basically two wheels. So let me draw it out. So we have basically two tires or something, or two cylinders. It's gonna be something like this, right? We're gonna use something like that, and then maybe this is a rail or something. Like it's gonna be curved, you know, something like this. I realize, God damn it, my artistic abilities is showing a little bit more than I need. Sorry about this. Hold on. So basically we have the ping pong ball. Yeah. That's the ping pong ball, right? And what I'm trying to get at is that these things, I drew in black. These things are rotating, so something like that, right? So actually it should go in the other direction. It should go this way. So those things are rotating around their axes, and basically the speed of these motors, so we'll connect these to some motors, right? Oh well, that doesn't make sense. Hold on, sorry. Damn it. We'll connect this to like a motor, right? Motor. M for motor. Connect those to some motors, which goes to like an Arduino, and then we can actually launch the ball. So the ball goes to here, the wheels speed it up, or squeezes the ball a little, speeds it up too, and launches it. So it just shoots out. We could do that. What else can we do? That's an idea that I came up originally because I think it was a given. We can also have, what else can we have? We can also have, I was thinking more of like a spring mechanism. So what we can do is something like I don't know, we'll have, I want to mix up the design. Okay, so we'll have something that, we have like a wall here, right? We'll have a wall here, and then we'll have like some sort of screw or rod. Wait, let me back up a little bit. We'll have some sort of like screw or rod that has a head, and then this will go to the back of that, and then we'll have like a spring coiled around, something like that, right? So it'll just coil around the thing, and then there'll be like some sort of like latch right here, and then we can control, basically, I don't know, we'll have like some sort of chain, I don't know, some sort of chain, and this will be like a sprocket or whatever they're called. Sort of like those gears that you see on your bike. So that's a gear. and then we could control how much it's wound up or something. I don't know. Maybe this is just a string, to be honest. Maybe a string and pulley. That might be simpler and cheaper. But and then this will be connected to like a motor or something. Connected to like a motor. Oh. Jesus Christ, that's louder than I thought. Thank you for subscribing, Ration, GG, thank you. I really appreciate the subscription. But yeah, so we have basically a motor, something that pulls the spring back, and this will be like the end of it, and then on here we just have the ping pong ball, so it could launch forward. You see the mechanism? Hopefully you can see that. So basically, the spring will compress or decompress, and how far it is uncompressed, it would determine the magnitude or power of the ball. But I'm very sorry about the tripod. It's on my desk. I'm using my desk for all my tools. Yeah. Yeah. Thank you for the. Yeah, X-Files is a pretty good show. It's a pretty good show. I'll give you that. Yeah. But yeah, sorry about the webcam. It's on my desk, and I'm using everything to basically hold my desk, including my lights, my camera, my mic, my keyboard. So I'll figure that out next stream. Actually, I do have a tripod, so I could probably put it on the floor, and it'll be the same height. Probably be more sideways though, but I'll figure it out. I'll definitely consider that. Yeah, I know this is my first stream. I actually spent the first hour muted, so it's pretty bad. So if you want to review it, I did go over it like 30 minutes ago, and if you guys want to watch the stream later, again, the archive will be on my YouTube channel, so feel free to watch that. But going back to the shooting mechanism, so what we have here, we have two motors, and these are like little wheels that basically get the ball in between them, and then the ball is launched by how fast the wheels are speeding. So yeah, I know it happens. yeah, but I'll try better tomorrow night for sure. So I'll keep that in mind. I can't believe how much goes into streaming, to be honest. It took me like the past week or two just to set up this stream, and it was kind of mind-boggling how much goes into it. Like, it goes more into it than the videos I produce, which isn't saying much, but I mean, a lot of work goes into this, and I appreciate streamers a little bit more. But yeah. Anyway, so we got the basically the tennis ball shooter. I'm gonna call that the tennis ball shooter. So that's the tennis ball shooter. And then we have this one over here, which would be, I don't know, spring-loaded shooter. I don't know which one's better so far. There might be a better way of doing this. There has to be another one. Oh, we could use a fan. I could tell you that much. I mean, maybe we could use a fan somehow. I feel like that's less controllable because it's like fan or like airflow is more unpredictable than like a spring. Like power measuring power is easier in terms of a spring or a motor than blowing air. So, but I don't know. We'll keep that in mind. So maybe we just have like a little fan, like blowing air, and then we just launch air at the. Again, this will be on like a rail. Well, maybe it's not a good idea, because if it was on some sort of rail, it might fly off. So maybe it'll have to be encapsulated, like some sort of like duct or something. So maybe some sort of tubing that goes around it, so we could control where the ball goes. To be honest, we might just use tubing for all these designs because it's easier to buy a tube than it is to buy a rail, I think, at least for a ping pong ball. So yeah, so the ball will just be launched. We could use a fan. That's a possibility. That way we don't need technically it is a motor, so we're just controlling it in a different way. So we'll call this the fan shooter, I guess. I feel like there's more ways of doing this. Sorry, I just had dinner. So yeah, if you guys have any other design suggestions, let me know. I'm more than interested, or to you guys' input. I mean, it's our robot. We could design it however we want. May or may not work, but that's the fun of it, and we'll definitely learn a lot. So how else do we shoot a ball? I'm trying to figure that one out. We could push it. We could launch it. Oh well, we could do like what do you call it? Like a medieval system, Like we could go with how do you say? Like we could do something like this. I'll draw it in the side view. So this will be like the motor. This will be like controlling the position, and then we could have like basically this something like a spoon, like that, and then we just basically rotate this thing. So we just have the ball here, and we can launch it. I mean, that's pretty simple. The only problem here, you don't really have much control besides how fast you want to rotate it. So all you have is power. So what we can do is make it retractable. I don't know how you would do this in terms of a design, but in theory, you can make it retractable. So maybe the base is huge, and then it gets smaller as we go out. You can think of it as a fire truck. You know how fire trucks have like ladders and stuff, or stuff like ladders, and they have to go up very tall buildings to save people. So we could just like have it retract up. And to think about it, maybe this is how fire trucks work, but I'm not sure, but I feel like I'm on to something. The cool thing about that, if we make the arm retractable, when I say retractable, let me draw it out better. So if the base is this wide, and then it gets a little thinner as we go up, and then even more thinner, and then really thin, and then we have the spoon. The cool thing about that is that the center mass slightly moves as you basically make this longer, right? So if we have this thing, right, the center mass is right in the middle, that's the weight. But if we make it retract or go out further, the center mass moves slightly to the right, because now there's more over here. There's some mass over here, and if we make it, I think you get the point. But the cool thing about this, if we make it thinner as we go out, we don't move the center mass as much, which can be helpful for stability. So that could be very useful. So we don't want the thing to tip over, right? If we make the arm too long, that could be an issue. It could tip over itself. So that's a concept. So it's basically a catapult. That's what this is. It's a catapult. How we design the catapult, I mean, this is probably the simplest design if we don't make it retractable. If we do make it retractable, I don't know how we would do that. They'll be like, I don't know. I don't know how we would do that. But that could be an option. What else can we do besides making it retractable? or well, while they're designing, can we throw a ball? Do you guys have anything to how any other mechanisms that could throw a ball? I mean, I could Google some stuff. I mean, that it's not like we can't use Google. Um, Let me see. We got motors. I think the key thing is that every one of these designs or concepts has a motor. So I don't think we're gonna escape that. And the cool thing is that we can control motors easily. So there's that. I can't see any other design. I'm trying to think of like a squirt gun or like a gun in general, how they're shooting, but they just bam or well, we could do actually we thinking about a squirt gun or a water gun, how they work. We could technically take that concept. I don't know how good it'll be, but we could take that concept. So let's see. So I don't know if you guys ever looked at a squirt gun, but or like the ones that you pump, if that makes sense. Like you like you like do this motion, and then it's loaded, so to speak, and you press a trigger and it launches water. Um, we could take that concept because it's a very simple concept. I don't know how we would do it though in terms of like a mechanism that we can control, but we'll put it on the list. So essentially, we could have like I don't know. This is where it gets more like hands-on, which I'm trying to avoid. But so we have like a pump. The pump pumps air into like a reservoir, right? It could be like a liter of soda, or like a plastic bottle or something. We could put it there. We could pump all the air into there, and then we'll have um, some sort of nozzle, and then we could have the ping pong ball be right there. You know what I mean? So basically, we we fill with air. We'll fill this with air, right? Then the valve will be closed, which will be creating pressure. We probably need a check valve here, so we'll need some sort of like check valve. I don't know how you would like well, it's a diode basically. It basically only allows air to go in one direction. So we'll have air going into the reservoir or pump. Well, this is the pump. The pump goes the air from the pump to the reservoir, which is stored, and then we'll basically create a high pressure container, which is pretty dangerous in some ways. We can have a high pressure container, and then we basically release the pressure by turning this valve, and then allow it to move the ball. So this is like an air shooter or something. You could do something like that. I mean, this one's kind of really out there because I don't want to pump up the ball. We can get a pump though, so that might be cool. Yeah, so we'll just have this as an air shooter. It's being launched. What else can we do? Damn, these are. I think I'm exhausting all these ideas. I mean, this is the heart and meat of this whole project. I don't know what else we can do besides this. We have basically a tennis ball shooter, spring-loaded shooter, a fan shooter, catapult shooter, and then an air shooter. I guess this is like more of a pump air shooter because we don't want it's not that different from the fan. So pump air shooter. What else do we have? I can't think of any other ways to shoot a ball. I mean, we can use gravity, but that's no fun. We can use gravity actually. Let's think about this. I came up with an idea. Maybe we can use gravity. That'd be very simple. This probably be the simplest of all the designs. So basically, what we can do We could have discrete units of power. You can also control the orientation, but you can't really control the vertical orientation. Which kind of you're limited on your degrees of freedom here. But essentially, what we can have is basically, I don't know, we have something like this. This is connected to a motor, and then you can think of it as like that theme park ride or something. And this will have like a lift with the ball on it. And then essentially we'll have different stages for the ball to go to. So this is like stage 1 or max power 1, if that makes sense. So we'll have like here, and then it'll go on the loop. I guess we'll draw that better. So it'll go like here, and then it'll launch, or it'll go up here, and then it'll launch, and then or here, and then it'll launch, or at the very top, and then it'll launch. So essentially, the ball is given power settings by basically how high it can go up on the ramp, and then it'll launch it. So motor. Ball. Right. So these are different levels, and this is like a ramp. So something like that. We could do that. Yeah. What else can we do? I think we'll call this the gravity shooter. I mean, it's a very basic design, probably one of the simplest, maybe, on here. Okay, we could use gravity. What can we use magnets? Maybe. I don't know how we would do that. Because the ball is not magnetic. We'll have to make it magnetic or something to cause it to be propelled by magnetism. I don't think there's much to that. I mean, these are the very basic designs. Although we have... And coming back to the spring-loaded shooter. Although we're using a spring, there's different ways to make it spring loaded, if that makes sense. Like, we don't have to use like a pin or a rod to launch the ball with a spring. We could use something else. Maybe it's just a pushing Oh, it's no different. That's basically what this is. Yeah, I don't know. Maybe I'm wrong about that. But be sure to let me know if you have any other ideas, whether in the comments or in the chat below. But yeah, if you guys have any questions about me or anything about my background or what I'm doing, stuff like that, feel free to ask. I wouldn't mind sharing some details. Yeah, so can I think of any other shooting mechanism? If I were a guy that makes guns, what would I make it out of? We could use rubber bands. See, that's more of that's okay. Now that's like the spring-loaded one. Like, yes, this is a spring in theory, but a spring could technically be a rubber band. In concept, they work in the same. The output is the same thing. It's just different design material. So we can even go deeper in each design to really optimize it. But we should, before we do that, we should actually choose one. So I'm trying to come up with as many ways as possible to launch a ping pong ball. I don't know. What else can we do? Hmm. I don't know. I don't know what else. If you guys have any ideas, again, feel free to shoot them. But I don't. No pun intended. But I don't. I think I'm out. I don't. Maybe I could sleep on it, come back to it tomorrow. But how else would you shoot a ping pong ball? The trend I'm noticing is that we're pushing the ball. Can we pull it somehow? I mean, it's like the plus and minus sign for like physics. It's the push or pull. Like, can we pull it? Can we? The only way I think about it is magnetism. You know what I mean? So that's what's coming to mind. How different can we make this? I don't know. I don't want to spend too much time on this because I don't want like dead air. But yeah, I think I'm gonna leave it at that. I think we have several designs to choose from. I kind of like the spring, kind of like the tennis ball shooter. I kind of like the gravity shooter simply because it's probably the most simplest, and maybe it isn't, but as far as I can tell, it looks like the simplest design. Maybe not actually making it, that's a different story. Like getting the material to actually make this, that's probably not a good aspect. But I don't want to do pros and cons yet. I want to go through everything that's on this list before I start choosing designs, because these might be dependent on each other, and I don't want to choose a thing that's best for this that's not really works with that, and we have a whole shebang. So okay, we went through. Let me check mark these so we know which ones we've done so far. So this is end goal. That's a given. Like, we don't need a design for that because that's the whole design. We already went through this. We already went through controlled through the internet. How we went through that. Again, if you guys want to see the whole explanation of this, I'll have it on my archived video on YouTube, so you guys will catch that. We went through the shooting mechanism. And just because I checkmarked this doesn't mean we can't go back to it later. We're probably more than likely are. We kind of already did the live video feedback, to be honest. Well, we didn't go in detail. We went through controlled on the internet, so we were talking about using this as basically a graphical user interface so you guys could see how to control the robot. So we'll see how that goes. But the live video feedback, we haven't really talked about what we're gonna use, so we could go into that. I think this might be the last thing we do if it takes long. So, live video feedback. This one's like not really really open minded, meaning like I kind of already feel like this is gonna be the way how we do it. But again, if you guys have better ways of doing it, I'm not much of a program software guy, so I may not be optimizing this to my best of my ability. So live feedback, what we're gonna do is basically use a Raspberry Pi, I believe. So a Raspberry Pi, simply because I already have the materials to use a Raspberry Pi. If you guys ever seen my video, that was my senior design project. Basically, we had a remote controlled vehicle with a camera on it so we could take pictures of trees without basically we were measuring tree circumferences, and these researchers have to measure hundreds of trees, right? And they have TAs, or not TAs, but interns, so to speak, or student TAs to measure it for them. But essentially, what they needed is a device so it allows them to not bend over on their knees and measure the circumference, because these trees are very small. They're low to the ground, or they were orange trees. So if you've ever seen an orange tree, it's a lot of shrubbery. Um, so you need a it's so the trunk that can be measured is near the ground, underneath the shrubbery, which is basically a foot or two off the ground at most. So they didn't want to crouch over and basically crawl to get to the tree circumference to measure it. So basically built a robot, well, not a robot. It is a robot, but like a remote controlled vehicle, and then we slapped a camera on it to take some pictures, and basically you drive the RC car to the tree and then take a picture and do your measurements and go on to the next tree. Should in theory it's way more efficient than what they were doing. So essentially what that means is that I already have a Raspberry Pi and a camera at my uh, accessible for me. So that's why I'm kind of leaning towards the Raspberry Pi. But if there are other ways to do it, then we'll definitely consider them. Again, this is all concept generation. So Raspberry Pi plus camera. I mean, how else are you gonna do video feedback without a Raspberry Pi? I mean, without a camera, I should say. Without a camera, you're gonna need something to control the camera. The Raspberry Pi. I mean, that's just a given, I think, at this point. And it's more, how do you say? It's more easy nowadays to use Raspberry Pi than it is to actually use a microprocessor or something to control the camera. We might be able to use the Arduino. I kind of looked into it, but it seems like everything works better, at least camera-wise, better with the Raspberry Pi. So, there's that. But other than that, we need software to work with this. I'm already thinking OpenCV, simply because I've used that before. I'm familiar with it. OpenCV. And to be honest, I think the Raspberry Pi has its own recording software. So we're going to use the basically innate recording software. Okay, what else? Raspberry Pi camera, OpenCV, innate recording software. So, like, how I think I'm gonna stream it to you guys, so you guys could see it, is I'm gonna basically open up my Stream app, which is Streamlabs OBS. I'm gonna add a browser, and then the browser is gonna detect the Raspberry Pi, and then the Raspberry Pi will be streamed within that browser, and then that widget is gonna be placed on the actual stream, so you'll see the stream. Maybe not the best route. Maybe I should host a little website to do it. Maybe that's a better route. But I want to do it through the stream, so it's kind of live. But there might be delay in that. I don't know how. It seems like there's about like 3-second delay or so. Hopefully my voice is not delayed. I didn't realize that. So hopefully my voice is not delayed. I don't think it is. Relative to what's happening on camera. Maybe it's kind of hard to tell when it's just text. But yeah, I think that's it. I don't know what else we can do with that. Raspberry Pi and camera. That's it. Unless we could yeah, there's no other way to do it. I mean, I can't think of any other ways to do it. I feel like this is the most simple route, but I could be completely wrong in that regard. Again, if you guys are into software or even Raspberry Pi, you guys know a little bit more, let me know. It's probably a lot easier to do it some way else. I don't know. The English is pretty hard. But yeah, there might be a better way of doing this. Yeah, I don't know. Well, we could also okay. Well, let's escape from the realm of the user, but think about the game in general. We're gonna need at least another camera. I don't have another camera, but if we had it, oh yeah, I do actually. I just need a cable, I think. Okay, I think we could do this. Okay, so we'll need so like let's say this is a game, right? We got a table. Uh, right, we got a table. I'll need a camera, probably on the side because it's easier to set up. So we'll need like some sort of, I don't know. I need like some sort of camera on the side. So that'll definitely help you guys in terms of feedback because you guys will be able to see maybe the game a little bit better than from the perspective of the robot. So maybe that's useful. So we'll hook this up to the stream. I mean, it's not really anything related to the design really. It's really going towards the stream than anything, but it's a good thing to keep in mind. Maybe this does affect the design of the robot. What else can we do? Yeah, I don't know what else we could do with the live video feedback. Okay, well, I think we'll leave that there for now. We'll come back to it later if we have any other ideas. Again, feel free to leave it in the comments below if you can't catch the stream, or leave it in the chat if you're still in the stream. Okay, so let's see. What's the next goal? Got live video feedback. We finished the live video feedback as far as we can tell. What else do we need? We need a power source. Power source and power transmission. So how we're gonna tell the robot to move and how we're gonna get the power to move. So this is pretty critical because without this, we won't be able to do anything. So power source and transmission. So what can we do? Power source, 9-volt battery, very simple. I have several of those. The only concern with a 9-volt battery, I don't know if that's enough juice to power both an Arduino and a Raspberry Pi. There may be an issue with that. I say 9-volt, I meant 9-volt. 9-volt battery. We could have multiple of these. You know, we could have multiple if necessary, one per device. But like the reason why we have it as a battery, so something like this small or something like that. The reason why we have batteries like that is to make it mobile, and we don't have to make it mobile. This is going to be a very stationary robot. It's not going to move much in terms of translation. It is going to rotate and do stuff within a spot, but it's not going to translate in space. So we don't really need a mobile battery. We can actually power this using like a power receptacle, you know, like the wall outlet or something. So we could use a wall outlet, like direct power. We could use basically a power brick or something if we have one of those at our disposal. So a wall outlet, we could use something like that. That's fine. What else can we use? Have a DC power supply. We could use that. That's basically using the wall outlet, but we have more control what power we send to the system, which is very very convenient. Because like we won't have to do any kind of rectification of the power signal. That'll be great, or anything like that. So have a DC power supply. That one I feel like we're gonna end up using simply because it's just highly convenient and it's super stationary. So it fits our criteria. How else can we power this thing? I mean, we could use a hamster and a wheel. I don't know. maybe that could be a possibility. What other power sources do we have? We can use water. uh, like can this be a? No, it can't. I was thinking like free power, so to speak, without like non-traditional power sources, which I don't know. That came to my head, but I don't know how to describe it because I really don't know what I mean by that. Yeah. So 9-volt battery, wall outlet, DC power supply. I feel like the wall outlet can work, but then we'll have to go create our own power system, and that is kind of dangerous because I'll be very I wouldn't like if you open up a power rectifier on your those power bricks or whatever, you'll see whatever's inside. The reason why those things are inside is probably save your ass from fire. So if I build my own, that's probably gonna be an issue. So, there's that. Uh, so there is that. Just to let you guys know, I am gonna end the stream at 8:30. I'll stream 2 hours per day. So just letting you guys know, per day, as in Monday through Friday. Hopefully, if I keep to that schedule. If you guys want to know more updates, check my Twitter. I'll let you guys know there, or even on YouTube. So there's that. And if you can't catch the stream, that's alright. It'll be archived on my YouTube channel, so you can watch it whenever you want. Okay. So, well, that's it. I don't know how else we're gonna power it. Those are very basic power things, at least modern ways to power it. Okay, well, that's more the power side. How we're gonna transmit the power. Where's the power going? I think a given is, I think it's pretty obvious at this state, is let me write it out. Motors. This could be DC, AC, or stepper. It's probably going to be stepper for most of these, right? We're going to use the stepper motor. Motors, DC, AC, so forth. The second type of power transmission, we could use we could use springs. I mean, the springs indirectly connect to the motor, which we'll see. So we use springs. That's not a problem. We could use springs. We could use gears. We'll put pulleys. I can't spell pulleys. / gears. And then we'll have string and chains. I like the pulleys and strings though, because it's cheaper and it's simpler in design, in my opinion. You don't have to spec out as much, Spring, chains. What other transmission is there? Fans. What else is there? I don't know. Let me know. I don't know. I don't want to think too much. I want this thing to keep going, because there's no room for silence. I want it to be continuously thinking, brainstorming, just something going, progressing. That's the word. Power and transmission. Let's look here. We got spring socket, air, fans, pumps. We can use pumps. It's a different type of fan, I guess, or motor. pump here. What else do we have? We have valves. Yeah, it's more of like a sensor, or well, it's more of a control. It's an actuator. That's really what it is. Catapult. I don't know. I really don't know. Like, those are the very basic power transmission things. Springs, pulleys, like things that get you going, gets the crowd provocative, keeps the people going. What else? Well, I'm thinking my car. What is used to move the car? We got wheels. You could use wheels. I think that kind of goes with motors, though. How do you turn a wheel with a motor? So it's like, we got wheels. What else do we have? We have gears, which we already have. We have, what other moving part is there? We have flow, which fans, pumps. What else moves in a car? Electricity moves in a car. Arduino, it's not really, I guess it is power. It's more of a controller than a power transmission. It's not like an actuator or something. Springs. Like springs for like suspension. But they're not really power actually. I'm just springs, suspension. What else goes in a car? Transmission, gears, shifting, handles. This is a tough one. I think that's it. I mean, what else can we use? Again, like a hamster on a wheel? Like, that's all. I think we exhausted this one. I'll let you guys know on this secret. It's not really a secret, really, but it's a website that can help you think and design different things. It's very exciting. So let me set this up real quick before we end the stream tonight. Hopefully I can set this up. Let me see. Oh, here we go. Sorry about that. Here, let me see if I could set this up. Oh, that's not supposed to be there. I did it again. Let me see. Can I show this? Yes. Okay. It's called McMaster-Carr. If you're an engineer, you probably have seen this quite a bit for parts. Essentially, it's a catalog of all these different types of parts. It's pretty cool. And you can just go through this and find new ways of doing things, or new tools, really. So they have a special section on here that can control power. Belts, that's kind of like pulleys. Gears, chain, yes. Gears, sprockets, drive rollers, track rollers, tracks, encoders, no. Turntables, no. Actuators, linear motion, that's basically where we're going, linear motion. Bearings, we might need bearings for all this rotational stuff, so we might keep that in mind, but that's more detailed design than constant generation. It's not, we don't need to be that detailed yet. Pumps, valves, hose, oil, reservoirs, we might need that. Pneumatics, yeah. Let's go over actuators. What kind of actuators we have? We use like a solenoid, actually. That's not bad. Wow. We could use a solenoid for some of this stuff. Let's put that down. I forgot about solenoids. Yeah, we could use a solenoid. It's basically a electrically controlled piston. That's what a solenoid is, if you guys don't know. So there's that. We could use that. How much are these, by the way? I'm just curious. Hopefully you guys could see this. Yeah, you guys should be able to see this. If I, let me zoom in a little. Okay, I'm not zoom in. Alright, that's cool. Okay, I guess I can't zoom in for some reason. But anyway, how much are these? 80, 50 bucks? Jesus Christ. Yeah, no. I mean, maybe. I'm not saying no because of the price. Whatever's the best design, whatever we choose, it's probably gonna happen. But Jesus Christ, 50 bucks? Okay. Okay, so it looks like all their linear actuators are just some sort of piston, which makes sense. Bearings. This got me thinking. Not really the positioning slides, but like, what if we like squeeze the ball and like it just pops out? How do you control the power though? Like if you just boom. I don't know. Maybe that's not really a good design. I mean, we could put it on there, but I don't know. I think that's really out there. Oh, I'm just curious. Huh. Okay. Okay. What else? What else do we have? We got a hose, springs. Shaft collars. Pulleys. I mean, yeah. Oh, what kind of pulleys do we have? Maybe they'll give us an idea. No. Okay, well, I think we got all the power transmission that I can think of. Pulling, lifting, ropes. Yeah, that's not really. This is what we're really gonna be dealing. Oh, now it works. Yeah, it looks a lot better. So yeah, belts, gauges, sprockets. This is like this is what I was talking about earlier. If I was not muted, like a bike chain, something like that. For the spring loaded one, we'll just like wrap it around a gear. Well, not wrap it around the gear. We'll use the gear to pull the spring or the chain somewhere else to wrap it around something. But to be honest, a better way would be a string and a pulley, and then we'll just use like the yo-yo concept. Like you have a yo-yo, the end of a yo-yo string connected to the spring, that is then that goes with the gear around the gear, and then wraps around some like motor or something, and then boom, and then it'll come back to play into like the original position because of the spring. So the rope or string will always be in tension. Yeah, that's the basic concept behind that. I mean, kind of obvious how I drew it. Okay, so what else? Yeah, I think that's it for. I don't think we need anything else. So we'll go back to that later. But I think I'm gonna end it there for tonight. I think because I don't want to start a new one yet without proper time, because I do want to end the stream by 8:30 because I do have work tomorrow and I have stuff to do before I go to bed. So there's that. So we got our power transmission, power source done. Store several ping pong balls. There's different ways to store them. So we'll finish this tomorrow. We'll hopefully get through everything by tomorrow, and then from there we'll go through choosing a mechanism, because that's the heart of the design, and then from there we'll be more detailed about the mechanism, and then we'll go to the next concept, maybe the power source and power transmission. We'll be a little bit more detailed, maybe spec it out, and then we'll go more detailed and maybe how we control it through the internet, So this is a very broad overview of how we're gonna maybe design this thing. So Hopefully tomorrow we'll finish the rest, six through nine. We could finish those, and then we'll start doing all the other design stuff. And then hopefully by the end of the week we'll have basically a good idea of how this thing will work. Maybe not the exact part list, but we'll have a good idea how it works. And then hopefully by next week we'll get started 3D modeling and see if there's any potential design issues that we're gonna face. I feel like I'm gonna use a 3D printer regardless of this thing, unless we could find parts that we could do everything with, maybe through Amazon or whatever, or eBay or stuff like that, or maybe have parts lying around my house. So we'll think about that. So yeah, I think we're gonna end the stream there. Again, I'm gonna give you a brief overview. If you still this long, what we're streaming, what we're really doing here is that I create YouTube videos. That's usually my main source of content. So I want to build things, design things, and to build and design things, as you can tell, can take a very long time. So it's not really a source of entertainment, in my opinion. I mean, it can be for some people, but it's not really like the really raw footage of me designing something. It's not really that entertaining. So it's not really a YouTube video, and for me to design something will take a very long time. So for you guys to interact more, maybe see how, maybe get your input on the design, maybe your ideas into the design, we could work together and create this robot. But the goal of these live streams is to give you more behind the scenes raw footage on how I design things, and ultimately gonna affect the YouTube video that I'm going to make with this. So yeah, that's basically the purpose of these live streams. I'll be streaming 5 days a week, ideally, if you get are at 6:30 PDT. I don't know the acronym for that. It's basically Los Angeles time, in California, so Southern California, that time zone. So from 6:30 to 8:30, it'll be a 2-hour stream daily for 5 days a week, Monday through Friday. If I can't make a stream, if I'll be late to a stream, or if I can't do something that day, or there might be an extra stream on the weekend, I'll post it on Twitter or even on my YouTube channel, the community page, and I'll let you guys know. But otherwise, just assume I'm going to be streaming 5 days a week at 6:30 to 8:30 p.m. Los Angeles time, or California time, so Southern California time. So yeah, there's that. Again, we're designing a ping pong ball shooter so that we could have a game between you and me over the internet, play some beer pong or something. I don't know, something crazy like that. But so you guys could have fun. I'll have fun. We'll have fun making it. We'll go through the whole process of building this thing, designing concepts, all that stuff. So hopefully you guys like this idea. I think it'll be great to show you, maybe learn more about me. I learn more about you guys, and you'll see a little how I think, how people will think, how these things come to fruition. So there's that. I don't want to ramble too much, but yeah. Thank you guys for coming tonight. If you guys can't catch the stream again, these streams will be archived on my YouTube channel. Be sure to check that out if you can't make the stream. And if you want to, don't worry, I'll be checking the comments to see your guys' input, whether it be making the stream better, making the design better, whatever you guys put in the comments in the YouTube video, I will definitely see. So don't be afraid. I'll be on Twitch, on YouTube. I'll be streaming simultaneously. So whichever two, I'll definitely check that out. So that's it. I'll see you guys later.